Okay, hi Precalculus, this is question number 1, part E of the chapter 6 review. So we're asked to graph this trigonometric function on a set of axes and then to state its domain range. What I like to do is try and, as I've been doing for each of these, try and give all the information that I could possibly deduce from this. A is 1, B, let's factor out a -4 to get x minus, or theta, my plus pi over 12. Because if I distribute, I get -4 theta minus 4 over 12, which is pi. So that's a really weird phase shift. But it looks like, I'm hoping we're doing this, that I'm going to be starting at -pi over 12, which is a pretty gnarly fraction. And we have a vertical shift of 1. Our domain is going to stay -infinity to infinity. It's a cosine graph. The range usually goes from -1 to 1 for cosine, and it hasn't stretched, but it has shifted up 1 unit, so it should go from 0 to 2. The period is going to equal 2 pi over -4, which is -pi over 2. Okay, so I'm going to draw my period in the negative direction, pi over 2 units. So let's see if we can really, I'm going to give myself a long runway here for a cosine graph. And then, so I want to go pi over 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, no, sorry. I just need to go, if I go pi over 2, 6 pi over 2, 7 pi over 2 would do it. Okay, so I'm just trying to plan ahead. You don't have to do it. 2, 3. Oh, you know what? I might be able to go up in threes. 1, 2, 3, 4, 5. Oh, just! It's like I planned it. All right. So we're just going to try and build our window. And I could have also let me shift this down because it's going to exist. I wasn't planning ahead there as well as I could have been. We don't actually need as much from the bottom. Right, what we do need is for this to have maybe more room up top because it's going to exist from 0 to 2. So I'm just trying to maximize the amount of space. Oh. Okay, I'm really hoping I do these calculations correctly. We're going to check it on Desmos because this is pretty. So we're starting at -pi over 12, -2 pi over 12, -3 pi over 12, -4 pi over 12, -5 pi over 12, -6 pi over 12, and -7 pi over 12. So usually something with a period of -pi over 2 would be that long, but everything, and it is, except it's shifted to the left. So I'm hoping my entire 8-pane window, and I'm going to, let's see, well, I'm going to make a really big graph. I was trying to plan ahead. Okay, so going up 2 units, this will be 1, this will be 0. And I can really cut off my 8-pane window here. Once I have these sort of parameters, I like to just build, I chop it up in half, and then I chop it up in half this way as well. Ooh. And I do that twice over because I want each of my 8 panes. If I did that correctly. Okay, that's sort of where it should be. Okay. So now I'm going to my cosine graph, but that's traveling in the negative direction. So I'm going to go, cosine means it starts at the max, mid, min, mid, max. I'm just going to connect them with a smooth curve, a sinusoid. Okay. And it seems like, I'm hoping, we're going to check this on Desmos, but I'm hoping we're going to have things y equals cosine -4x, and I'm going to plug in the original function because I could have made a mistake even. I'm really hoping I did. +1. Ooh. Oh, so let's put in some parameters. Let's put y equals 1, y equals 2. Let's put x equals -7 pi over 12. And let's even put x equals negative pi over 12. Oh, no. Maybe. Oh, it looks like I've got one sinusoid, but one cosine period existing within that, and it looks like it bottoms out at negative pi over 3. And I think I plugged in the correct original function. Okay, this was quite a gnarly one. And it doesn't have to look exactly like this, but if you're able to plan ahead and stretch things out, it's going to look like a sinusoid anyways. It's just that your axes are going to be shifted. All right, hope that helps.